Welcome to the channel today. I'd like to present one of my favorite books. It's not a book in fluid mechanics or heat transfer, but it's a book on very important topic of applied mathematics, asymptotic theory, advanced mathematical methods for scientists and engineers, and the authors are Bender and Orszag. So it focuses specifically on approximate solutions of ordinary differential equations. Just a word on the authors. They're both world-class physicists. Bender is an expert, world expert on quantum mechanics. Orszag was an expert on fluid mechanics. So they wrote this book together. It has almost no physics, but I must say it doesn't matter because all this idea can be applied to probably all the areas of theoretical physics. And specifically, my interest is on fluid mechanics and heat transfer, as you know, and of course, these techniques can be applied in these subjects. So if you want to buy a book on applied mathematics, I suggest you buy and study this book. So I can say it's rigorous, it's well written, and it's comprehensive. And so let's go through the table of contents. So the first chapter is on ordinary differential equations. I must say, if you want to embark on studying this book, you should already have a very strong grasp on ordinary differential equations. So before reading this, this chapter, I suggest you spend quite a long time revising and study ordinary differential equations. So you find a lot of course, ideas here on ODEs, but this is just given as an introduction. So this focuses on exact solution or on ODEs, and then it also treats difference equations. So the most interesting part, of course, starts on part 2, local analysis. So in this case, studying behavior or ODEs at specific points, including infinity. So the main idea here is that a point in the domain must be classified as an ordinary point, a regular singular point, or as an irregular singular point. And the main ideas of asymptotics is to find the behavior of solutions near irregular singular points. So chapter 3 is on linear equations, and chapter 4 is on nonlinear differential equations. Then the same ideas are applied to difference equations, and then chapter 6 is on approximate solutions and behaviors of integrals. And I think that part 3 is even more interesting now, is introducing the concept of perturbation series. So the reader up to this point might be used to the idea of series, that when a series is useful to study a physical problem, the series is usually convergent. But in asymptotics, a lot of series are actually divergent. So the author just introduces this new idea, and then in chapter 8, it gives different ideas of how to sum a divergent series. So that's really, really interesting, and specifically, the authors are keen on Padé summation. Then chapter 4 is on boundary layer theory. So boundary layer theory, Wkb theory, and multiple scale analysis. So in this part 4, in these 3 chapters, the idea is to find approximate solutions that are valid everywhere in the domain, not like in the case of local analysis, solutions that are valid in one point of the domain. So in boundary layer theory, introduces the idea of a very thin layer where there are very high derivatives. First and secondary are quite high. And then introduces the concept of match asymptotic expansion. Whereas Wkb theory, for linear equations, it finds solutions that are actually valid everywhere in the domain. And multiple scale analysis is an asymptotic theory that includes the Wkb theory and boundary layer theory as special cases. I really like also this book. There are a lot of quotes for Sherlock Holmes. For each chapter here, he has a quote from, you know, one of the books from Sir Arthur Conan Doyle. Really, really a bit of humor. Each chapter has a lot of problems. You can see, for example, chapter 5. See how many problems to solve, and I suggest you try these. And of course, the different levels of difficulty. So let's see one of the chapters, how they're structured. For example, chapter 10, one of my favorite chapters, 484. Here, Wkb Theory. Usually the introduction here is quite brief but very clear. In this case, introduces a simple ODE with a small parameter epsilon. For this equation here, we have analytical solution. So for this special case, it's using the asymptotic techniques and compares the approximate solutions to the analytical solution, and see how they compare as epsilon becomes smaller and smaller. Then it gives a formal WKB expansion, and always when it gives the expansions, it clarifies the idea of a lot of examples. So here you have example 1, 2, and I suggest, as I did here, you just go through all the examples and to have a very clear grasp of the theory. The graphs and the figures are also very clear. What's lacking in this book is probably the application, but it doesn't matter because you just focus on the maths. And you can find application in other books. Turning points. So this is a situation where the WKB standard approximation breaks down some local part of the domain. Here there are some applications to quantum mechanics. So really a lot of examples, a lot of clear graphs. Maybe scary and daunting in the beginning, but when I actually get into that and you do it systematically, you see it's very, very clear. So again, I think this is, for me, is the book that taught me most in applied mathematics, so I really suggest it, and I hope you enjoyed this video. Thank you very much.